Okay, solving the following, finding derivative of the following equation. Y is equal sine x to power 5 minus cotangent square x. Okay, so derivative of sine is cosine. All we know, right? If I put sine u instead of x, then it's going to be cosine u times u prime, right? Because it's not a standard format, which means we have to take derivative of that u also. Okay, so let's do it. Derivative of y is equal cosine x to 5 minus cotangent square x. Okay, cotangent and cot, it's the same thing, okay, just so you know. Minus cotangent square x, and then times derivative of this u of the sine, that's our u. So it's going to be 5x minus, now cotangent square x, it's also, I'm going to get a chain rule. It's going to be 2 cotangent x, right? And then I'm going to multiply by also derivative of cotangent. Okay? Let me see if I jumped too much. So derivative of sine is cosine, okay? And then we take derivative, multiply, this is our u prime, derivative of this u prime, x squared minus cotangent square x. So will be derivative of x to 5, 5x to 4, I'm sorry, missed here 4, and then minus 2 cotangent x, yeah, cotangent square x, it's going to be 2 cotangent x, and then times derivative of cotangent x. So derivative of cotangent x is going to be negative cosecant square x. All right? All right. So 2 cotangent x times, practically it's going to be cotangent x prime, which is going to be times negative cosecant square x. Yes? All right. So we have y prime is equal cosine x to 5 minus cotangent square x, and then times 5x to 4 minus 2 cotangent x, and times negative cosecant square x. Okay, so what do we have from here? Cosecant square x, I'm going to break down as a 1 sine square x, right? Okay, y prime is equal cosine x to 5 minus cotangent square x times 5x to 4. So here we have negative, multiply by negative, it will end up with, excuse me, plus 2 cotangent x over cosecant square, I'm going to write down as a sine square x, right? Because what? Cosecant x is 1 over sine x, right? Okay, so, and this is how far we can go from here. Nothing further we cannot do. Let's say even if you take cotangent, simplify into the cosine divided by sine, right? It's not going to help much. And besides, we have here cotangent and we have here cotangent also. Okay? All right. Next one. Moving to next one, which is going to be y is equal, number 2, y is equal cosine 2x over e to power 2x. I'm going to rewrite it and write down in the form of product. E to power negative 2x. All right. What is it going to be equal? So, y prime is equal derivative of 2x times e to power negative 2x plus derivative e to power negative 2x times cosine 2x. All right, let's work on it. Y prime. So cosine 2x is going to be sine, negative sine 2x, right? Because derivative of cosine x is negative sine x. And getting inside, derivative of 2x is going to be 2 times e to power negative 2x. Okay, next. Now this is more interesting, taking derivative of e to power negative 2x. We already know derivative of, let me take this time derivative of u prime. U prime, well, we consider x as a standard. If we have u, which means it's not just x, but some expression, then we are going to get e to power u times derivative of u. Chain rule. Okay, so that's mean I'm getting e to power negative 2x and then times derivative of negative 2x. I don't want to jump here so people would understand. Okay, and this is equal, y prime is equal negative to, let me put e to power negative 2x first and then sine 2x. And then derivative of negative 2x is going to be negative 2, right? Minus 2 e to power negative 2x times cosine 2x. All right? So from here, y prime is equal, I'm taking out negative 2 e to power negative 2x and in parentheses sine 2x plus cosine 2x. And as a result, we will have negative 2. Okay, well, so I started with cosine, that's okay. 2x plus sine 2x. And all that we divide by e to power positive 2x. And we are done. That was question number 2. Question number 3. We have y is equal e to power x to power 1. Let me make it more interesting. Is equal square root e to power x times natural log sine x. Okay. So, what do we have? I'm going to rewrite y is equal e to power x to power 1/2 times logarithm sine x. This is going to be equal e to power x over 2, because power to power, we multiply, and times natural log sine x. From here, y prime is equal derivative. Since we have product, it's going to be e to power x/2 prime times natural log sine x plus derivative of natural log of sine x plus, you see here, chain rule, yeah, and times e to power x/2. All right, so y prime is equal derivative of e to power x/2. It's going to be e to power half of x, and then times derivative of half of x, right? Times natural log of sine x. Okay. Next, plus, so e to power half of x and derivative of natural log, it's going to be equal 1 times 1 over sine x, right, times derivative of sine x. So let me write down the natural log u prime. When I put u and not x, that means u is expression. It's not a standard x. So it's going to be 1 over u and times derivative of u. Here it is. My u is sine x, 1 over sine x, and times derivative of sine x. Okay, from here we are getting e to power half of x, or I can write down e to power x, right? Because e to power half of x is equal e to power x to power 1/2, which is going to be square root of e to power x. Yes? All right. So e to power, square root of e to power x times natural logarithm sine x, right? And then plus e to power x/2. Okay, we have another e to power x/2. I guess I can might as well take it out, huh? Put here parentheses. So I will have natural logarithm sine x, and derivative of 1/2 of x, it's going to be 1/2, right? 1/2, here is 2. Okay, plus, so e to power half of x is got out, yes? And what do we have here? We got sine derivative of sine x is cosine x. Let's do drafting here. 1 over sine x times derivative of sine x. It's going to be equal. Derivative of sine x is cosine x. Cosine x over sine x, which will give me cotangent x. So finally, for this, the whole piece, I will put cotangent x. And that would be our answer. And we are done. All right. So let me clean this. so it won't look messy. Okay, that's all. I think I will finish by this solving derivatives because we solved quite a few and we did relatively complicated ones. So if you can understand and solve this one, the other ones will be easier, I would say. Okay, thank you for watching and see you in next video. We will start something new, or maybe more of limits. I will do limit of sine x over x. We'll see.